Alright, so today we'll talk about the last section of this chapter 5, which is section 5.5. Now in this section we'll be solving the trigonometric equations. So before we start this section, let me remind you that we know how to solve the equation. Okay, so trigonometric equations is nothing different than the other equation solving techniques in algebra. How we solve the equation, still we'll be doing the same thing, and also we'll have some equations which are quadratic. So except some, like because you know that whenever you are solving the trigonometric equations, you will have all those 6 trigonometric functions, sin x, cosine x, and whenever you will see sin x, cosine x, you have to consider you have to find their angles basically for different values of the sine, cosine. For an example, if somebody tell you that, okay, sine x equals to 0, now what is the value of x? Now in such cases, we have to always remember or retrieve from our memories, or if you want to write it down somewhere, or if you get it from the previous sections, from the tables we have shown you in the previous sections, that because that for which angles sine x becomes 0, because you know that sine, cosine, tangent, and all the 6 trigonometric functions, since they are periodic, their values are being repeated. So whenever you see that sine x equals to 0, you will always assume that x has a multiple value of multiple angles, because for multiple different value of x, sine x can be 0. For an example, for sine 0, sine x is 0, right? I'm saying for x equals to 0, sine x is 0, because sine 0 degree equals to 0. So x equal to 0 is a good is a value for x here, and at the same time, sine 180 is also 0. So anytime if you see, for an example, if anywhere during your solving equation, you know, before I start, I'm just trying to give you some idea that what you will be expecting. Let's say sine x equals to 1. From here, what do you know? You know that x can be 0 degree, because for sine 0, sine x equals to 1. I'm sorry. Let's say this is 0. Let's make it 0. For sine 0, sine x equals to 0. X can also be 180, because for sine 180, still we have sine x equals to 0. Even if x is restricted, let's say somebody said that x cannot be greater than 360. So under that restriction, you know that for two values, there are two values of x for which sine x can be 0. So we always will be considering all the possible values of x for which sine x becomes 0, or for this case. Okay. So remember that point, because you know, since all the trigonometric functions are periodic, and also you have to remember, I think you already have all those information in the formula page, because we already discussed about those in several other sections, that they are periodic, and so what is the length of their period. For an example, in case of sine and cosine, the periods are 2 pi. That means after every 2 pi, all the values are being repeated, because their period are 2 pi. But in case of tangent, in case of cotangent, the period is pi. That means after every pi, the values are being repeated. So we have to be careful about that as well. That after how, meaning what is the period of the trigonometric functions. So similarly, since the sine, cosine, and the cosec and sec and cotangent, they are reciprocal to these, so we will be able to find the period for those, and they are similar to sine, cosine, and cotangent. Now let's look at a couple of equations here. In this chapter, we'll not be covering any new concept. The only thing is, we'll look at a lot of trigonometric functions. Some of those functions will be also quadratic, meaning there will be some term with square, like sine square, cosine square. And we'll be using the same kind of steps that we do when we solve the algebraic equations, except a couple of things that I just talked here, that we have to consider all the angles within a restriction. Now let's look at some examples, and we'll be doing all those practice. So let's look at some of the examples. As it just, this is again a reminder that all the trigonometric functions are periodic and all the values are repeated. For an example, let's say if somebody tell you that, okay, this equation sine x equals to half. What is the value of x? Now you see here, if you look at the graph carefully, the red line is the line for x equals to half. Do you see the red line here? The red line is the line for the half. You see how many places the blue graph is intersecting the red line, right? Because there are infinite number of points where x equals to, sine x equals to half, right? Because it's periodic. After every single period, the value is repeated. Now let's say somebody restricted that. Somebody said, okay, we will not take any value of sine x except which is larger than 180 or less than 0. So let's say the restriction is 0 to pi. The 0 to pi. If somebody tell you that, if the value is like from 0 to pi, then still you have 2 points here. Do you see the green points? 2 green points here. So with all the trigonometric equations we'll be solving, not with all, I think most of those will have restrictions given, and we have to find the values of x's, sine x's within that restriction. So for an example here, again, I just wanted to remind here, the equation was sine x equals to half. Okay. In case of the algebraic expression, we know that for any algebraic expression, if it is like, for an example, let's say we are solving an algebraic equation of x, okay, and the power of x is 1, the maximum power of x. So we know that doesn't matter how you solve it, there will be only one value of x. Similarly, if you are solving a quadratic equation where the power of x is 2, then you know that there will be 2 value of x. Okay. If you are solving an equation of like x to the power 3, then there will be 3 value of x. That's what exactly we do in the algebra. But here it's a little bit different because of that periodic issue. Because of the periodic issue, it doesn't matter, because there is no in the sine x, there is no power of x, there is no power of sine square, but still we have 2 value within even that restriction of 0 to pi. So we'll be always looking at those things, because since everything is periodic here, it doesn't matter what trigonometric functions you have. And also we'll be careful about the period, because the periods are different. Sine and cosine has 2 pi, tangent, cotangent, they have pi. Now let's look at some, here is the starting point. Now 3 sine x equals to pi 3 plus sine x. Now remember, we'll be always trying to solve the equation for x. Okay, so we'll be always solving the equation for x, and also just as a clue, x will be nothing except an angle. You see, x will be an angle, and since we try to follow the convention of the book, and MyMATLAB also does that, so we'll be also using only the radian here for x's. But if you understand better in degree, you can solve the problem in degree, and then later on you can convert it to pi, into radian if you want. Now here, if you look at carefully, since we are talking about solving an equation for x, the x is being restricted, because look at the equation carefully. They solve it for x where x is restricted between 0 to 2 pi, because they always want to do that, because all the values will be repeated otherwise. Now let's try to see whether we can solve this equation. Then the later ones, I'll give you the chance, and then we'll do it later. Let's try to see whether since this is the first one, let's try, and this is 3 sine x equals to square root 3 plus sine x. Now remember, since we are trying to solve the equation for x, we always want to isolate the x in any side, let's say in left side or right side. Now here, since we have x in both sides, we want to isolate it in one side. Now since you want to do that, you may want to subtract sine x from both sides, because you want to get rid of this sine x maybe from the right side. So we are subtracting sine x from both sides, because we just want to get rid of sine x from the right side. Now at this point you will have 2 sine x equals to pi 3, the square root of 3, and then sine x is going to be, if you divide both sides by 2, just like the regular algebraic equation solving steps, you will have square root 3 by 2. Now at this point, see here we have sine x, which is equal to pi by 3. Now think about square root 3 by 2. If you look at this one, think about where sine x equals to this. It's 60 degree in general, right? But remember, that's not enough, because if we draw the quadrant, now here let's say this is your 60 degree, okay? Now remember, the value of the sine is being repeated almost in every quadrant. Now what happens? Now here this is 0 to 1. I'm saying it starts from 0 and go all the way to 1, and then again here it starts from 1, go all the way to 0, because in sine 80 the value is 0, okay? And here it starts from 0 and go all the way to -1. That's how it basically repeats. Here is 0, and then this is 1, and here again is 0, is -1, and again here it is 0. So the values are repeated within 2 pi, but all the values are repeated. Now remember, since the values are repeated, this value of sine x will be again repeated somewhere. Now let me give you some clue. The first clue is, look at the value of the sine. This is positive, right? Now from here you will always guess that the other angle you were expecting, that must be somewhere where sine x is always positive. Now from that point of view, you can always ignore the quadrant 3 and 4, because you know that the quadrant 3 and 4, the sine x is always negative. So there is no way you will have that x in quadrant 3 and 4. So the only chance is 1 and 2. So you already have 1 for 1, which is 60 degree, right? Because you know that's 60 degree. Now what will be the other one? That must be here, right? So how do you know it? There is a way of knowing that, which is this. You know that x is, for an example, from here, from this given information, you of course know that x is pi by 3, because that's 60 degree. You know that for sure, right? What can be the other value? You will know it from here. Since you know that that is in second quadrant, you can always subtract it from pi, something like this. This is in second quadrant, right? So what we can do is, we can check like this. We can always add pi with that, or you can always add, you can subtract it from pi, or you can add it with pi, or you can subtract it from 2 pi. But you will always know where will be the quadrant, because I cannot add with the pi here, because if I add the pi, it will be in quadrant 3, right? If I add like pi plus this, it will be in quadrant 3. Or if I do, for an example, let me write all the options that I have. In this case, I could have all of these options, because I could have this option, I could have this option. Let me write all the options first, and then I'll let you pick which one we will never have. Now, see, since the values of the sines are repeated at all of these points, because you see, it's simple. You don't have to think a lot. The only thing that you have to do is just you have to subtract it from pi, or you have to add it with the pi, or 2 pi. Okay. Now, if we do this, look at this. This is not valid, because this is in third quadrant, and sin x is positive here. So ignore this one. How about this? This is in quadrant 4. You see that? This is in quadrant 4, because it's 360 minus 60, which is 300 degree, which is in quadrant 4, which is again sign negative there. So we disregarded that. How about the last one? What is the problem with the last one? Last one is fine, because this is in quadrant 1, because you again started 360 plus 60. But the problem is this. Look at the restriction of the sign, restriction of the x. X cannot be larger than, so anything after this point, ignore it. So the only thing that we are left with is this. So there are two possible value of X, which is, one is of course pi by 3, and the other one is what? 2 pi by 3. So these are only, so let me erase the other options because we ignore it. So so these are the only two values of X for which your sin X is going to be pi by 3. I'm sorry, I always do it by mistake. So square root of 3 by 2, positive. Okay. So these are the two solutions of X. So here again, as I said before, the only thing which is different is even if this is an equation of X, still we have two values of X because the values of the sines are all the trigonometric functions, including sine, they repeat. Okay. Any question here? Any thought? Okay. So every time, because I know that the first couple of steps are straight because you just like the algebraic steps. At some point, you have to think that what happens here. Okay. If it is negative, for an example, if this is negative, if we get something negative, then we would first think that the value would be, since it is negative, it must be in quadrant 3 or 4 because these are the only two quadrants where the signs are negative. So the value would be what? Pi plus pi by 3, 2 pi minus pi by 3, because those are the only two possibilities you will have. Okay, which we ignored this time. Now let's do some more practice because I'm sure that once we have some more practice, let's try this one. Again, this is with the sine, very similar problem that we did. Once you solve it, you will have something similar to the one that we just tried. And you'll be solving the equation for X. Alright, so what is the value of X? So let's look at the equation here. 2 sine x by 2 equals to 1. So it's very simple. If you divide both sides by 2, you will have sine x by 2 equals to half. So at this point, we'll be looking at what are the, see, first of all, the sign is positive. So and then it's restricted by 2 pi. So you will know that since this is positive, it must be in quadrant 1 and 2 because those are the only two quadrants where signs are positive, right? Quadrant 1 and quadrant 2. 3, 4, no, because they are negative. Now, quickly we can tell that is sine what? Pi by 3, okay? Sorry, pi by 6 because it's 30 degree, right? Sine 30 is half, right? So let's write x by 2 equals to pi by, because this is x by 2, be careful of that. X by 2 is pi by 6, first of all. What else? We can also take, this is option 1 maybe. We can also take this. We can also take pi minus pi by 6, because this is in quadrant 2, right? As I said, remember, you can add, subtract with pi, and from pi you can subtract, and you can add with pi and 2 pi, but depends on what quadrant you are going, because you cannot go to quadrant 3 and 4, so we disregarded those because your value is positive so far. Now here for this one, what will be the x? Because you will have to multiply both sides by 2 again to get the x, since it is x by 2. If you do that, it will be pi by 3. So this is one value of x. And if you again here, x by 2 is 5 pi by 6, right? And then x is what? X is, if you do multiplication, both sides if you multiply it by 2, so you will have 5 pi divided by 3. So these are the two possible values of x, and we always double check with the restriction. Look at the double restriction. x cannot be larger than 2 pi. So we are still within the limit. So we are still within the limit. Any question here? See, at this point, we are just learning. Over the time, I'll show you some more advanced techniques, but to apply this kind of, to using this kind of problem. But these are the only two values we have, because every time you are multiplying, because you are getting x by 2, and then you multiply both sides by 2, so almost the angle is getting doubled. So you cannot take any of those values. How do I get 5 pi over 3? I multiplied both sides by 2 because it's x by 2 here. I multiplied both sides by 2. Oh, how I get this? Okay, there are a lot of different ways of getting this. If you multiply it by 2, what happens? You can cancel this by 3. I don't know exactly. Yeah, there are probably other different ways. It's up to you. Yeah. It was a subtraction, but then we multiplied both sides by 2, and then this is how I think. It's up to you. But what do you think is a factor of what? 3 times 2, then you cancel 2. Any question here? See, over the time we'll be doing a little bit more advanced techniques. We'll show you. Okay, now here, look at this one. Sin x plus cos x equals to 0. Okay, any quick guess that how do you start? How do we start? Any quick guess? Say it again.
Sin x equals negative cos x.
Then, after that, see, you always want to have, just as a tip, you always want to have one trigonometric functions in one equation. If you have more than one trigonometric functions in one equation, it will be complex. So from this equation, can you do something to convert it to only one trigonometric equations? Because one trigonometric function. There are two functions at this point, right? Trigonometric functions, sin x and cosine x. Can you do something which will convert this equation with only one trigonometric functions? Any guess? This, just think about this from the algebraic standpoint. At this point, we are just talking about the algebra because you have to do some kind of algebraic things. Maybe, okay, how about this? How about if you divide both sides by cosine x? What happens? Okay, and then sin x becomes 10x. You just will be left with only one trigonometric function. You just want to have one trigonometric function in one equation. If you have more, try to make it one. Apply all the trigonometric identities or maybe whatever you want. So here at this point, you can just divide both sides by cosine x. If you do that, it will be converted back to, because the equation is sin x plus cos x equals to 0. And then if you divide both sides by cosine x, this becomes sin x over cos x. This becomes cosine x divided by cosine x. And this is 0 because it doesn't matter what you divide by that, it will be still 0. Now here this becomes tangent x, and this becomes 1 equals to 0. So from here, the tangent x equals to -1. Now it's simple now. What is -1 for tangent? What is that angle? What is the negative tangent? What is the negative for tangent? $225. How much is that? $1045 equals to 1, but we have the negative value. Okay, now, first of all, how do you proceed? Any clue? Now remember, the tangent, the period of the tangent is pi. So after every pi, all the values of tangent will be repeated. Now let me show you a simple trick that you can apply in such cases. Now first of all, you know that let's forget about this negative sign. Now you know that 1045 equals to 1, right? I think we all know it, that 1045 equals to 1. So let's write that something like this. Minus, just minus as it is. Just for 1, we are writing 1045, which is pi by 4. We still have 10x here. Now what kind of function the 10 was? Was it an odd function or even function? See, all the functions are odd functions except cosine and sec. You will need all the knowledge that we have so far, except cosine and sec, because they are reciprocal. Except those two, everything else, all the 4 other trigonometric functions are they are odd. So from that standpoint, negative 10. So negative tangent 45 is basically your this, because of that odd function issue, because f of minus x equals to minus fx. That's what we have for every odd function, right? So we also have that. Let me check whether we have that. I think we had it. Let me check that. Whether See, if you look at the last page of the our formula page, you will probably have it here. Except the sine and cosine, sine and sec, you will see all other functions are odd functions. So they are under even and odd identities in the column 1 of the last page of the formula pages. You see? Now from here, it's a little bit simple at this point. So what will be the x at here? Now from here, x is negative pi by 4, right? Because 10x equals to 10 pi by 4. Now, can we take that value? Can you take that value? Look at the restriction of the x. You cannot take that value, right? So we cannot. We basically cannot take that value of x. So that's interesting. So what do we do? Because we cannot take the value of x. But we can do this, because if you think the quadrant, where we are, if we have the negative 45, where we are really? This is the quadrant. If it is negative, we start from here and go to the right, right? So we are basically here. Because we started from here and we are going clockwise because that's negative angle. But at the same time, remember, this angle is nothing but this positive side. You see what I'm saying? Because that's the same angle, because it's, if you're considering the negative side, it's negative 45, which is basically equal to what? 2 pi minus 45. You see what I'm saying? It's 2 pi minus 45. So this is nothing but 2 pi minus, which we can take for sure, because this is lesser than 2 pi. And also, if you look at this carefully, remember the tan x was negative, right? So your tangent will be either here or here, because this is, or here maybe. Oh, no, not here. Not here, I'm sorry. Tangent is negative, so it should be either in the quadrant 2 or quadrant 4. Why? Because first quadrant, everything is positive, so tangent is not here. Quadrant 3 is for the tangent quadrant, right? So tangent is positive in this quadrant. So we disregard quadrant 1, quadrant 3. We'll be left with 2 and 4. So we already have something for 4, right? That's in 4, right? 2 pi minus pi by 4, that is already in 4. Now how about 2? In this quadrant, tangent is negative, right? So if you think like this, because technically that is the angle, which is again pi minus so this is one value of x, and the other value of x is pi minus pi by 4. Try this one and see what is the value of x here, the tangent here. So it's here, this is what, 7 pi by 4. What is that? 7 pi by 4, and this is 3 pi by 4, right? So those are the possible two values of x. So so most of the cases what you do is, as I said, you add with x or you subtract with you add with pi, or you subtract from pi, or you add with pi. So we'll do all of those and see where it basically falls, because we have to also check with the quadrant. So at this point, these are the only two options we had for which the angle is falling either in quadrant 2 or in 4, because we cannot put our angle into 1 and 3, because in those two angles, those two quadrants, the tangents are positive. Our case, the tangent was negative. So those are the only two places we had. Any question? So here, I think the solving the equation is not hard, but the finding the value is a little bit tricky. So you have to always spend a little bit to understand where the x will be falling based on the situation right now. First of all, you can disregard those quadrants based on the sign, which is easier because you'll be disregarding at least 2 quadrants for sure. So other 2 quadrant, you can find it out based on what you have. So let's check whether we can do the another one. So here again, remember the clue. We always want to have one trigonometric function in one equation. I'm not sure, that's probably not written in the book, but that's the way, because otherwise you will run into another problem, because you will not be able to solve the equation. So you want only one trigonometric function. At this point here, there are 2 different trigonometric functions. One is tangent and one is sin x. So you must want to get rid of one. It's up to you which one you want to, or which one you find easier to, because there are probably multiple ways of getting the same equation solved, having different trigonometric functions in one equation. But one step or procedure may be easier than other. So you should always look for those. This should be easy, right? Because it's just like, what do you did? How do you start? Yes, that's probably one of the easiest way I see here. You probably have like other definitely other ways, but that's probably the easiest one. If you divide both sides by sine x here, so it will be 10x equals to 1, and then x equals to what? 45. But that's not the only value of x, right? That's the point, because we have x equals to, so the tangent is going to be 1, because it's tan 45, but the 45 is not the only value of x. What are the other values? Any guess? 225? Is that the value of x that you guess, everyone? Because look at this. This was 45 here. Now, first of all, since the tangent is positive here, what is the guess? The guess is it must be in quadrant 1 or in 3. Because these are the two quadrants where tangent is positive. So here we already got one value, and the other one must be here, right? We just basically extend it logically, because that's how it works. I'm not sure. I'm sure, in fact, the book doesn't show you in this way, but that's the way I learned when I found that's exactly what happens. So because it's in other third quadrant, so you just add 180 with that. So 180 plus 45. So the x is going to be here. X is one option. One is definitely this, and other one is x equals to pi by this. So now this one is 5 pi by 4, and this is, so we have these two values, and that's it, because you cannot go further beyond 2 pi. So you have to disregard these and these, quadrant 2 and 4, no, because in those two quadrants tangents are negative. Any question here? Any comments, question? We want to hear comments from you, like too easy, too bad, too funny, something like that. So, this. That's true, but at the same time, sometimes if you are really positive, you will find always the positive side of any comments. Because for an example, let's say one of my teachers told me at some point, because he was a little bit philosophical, so he was teaching me, like, let's say you have a half glass of water, okay? Every different person in the world, they will explain these in different way, because some people will tell you that, okay, we have half glass of water here. Some people will tell you that the half of the glass is empty. Again, it's up to you how you see it. Both of the statements are true, but it's exactly up to, because if both of the people are saying that, okay, this is too easy, third person might think, okay, still probably it's easy, I probably get there, or somebody might be frustrated, oh, it's easy for them, not for me. But again, as I said before, that doesn't matter it's trigonometry, doesn't matter it's algebra, doesn't matter it's something else, pre-calculus or whatever. The best way of mastering all these skills is to practice, and no option except this. There is no shortcut, and if you don't see it easy right now, that's because you did not have enough practice yet. And that's exactly what we are looking for here. Nothing else, nothing different. And that's true for me, that's true for you, that's true for everyone in the world. Now here, you see, I'm not trying to scare you here, but look at the original equation, which is tan 3x equals to 1. Now, as I said before, at some point we'll try to be a little bit more smart, and this is exactly what we are trying right now. For an example, because this is probably a little bit more generic version of solving equation. Generic, I'm saying this little bit generic version. Now let's see, what do I mean by the generic version? Okay. Now, without looking at there, let's see whether let's try to solve an equation which is tan 3x equals to 1. The first line, that's the equation. Let's say we have tan 3x equals to 1. Now, what we basically want to do in one equation to solve it. Now, so tan 3x equals to 1. Now, first of all, from here we know that for sure that 3x equals to pi by 4, right? How? Because 1 is 10 pi by 4. That's the first basic assumption we had, because that's, but remember, you will see, even if you look at the book, in most of the places, they don't write it like this. I'm just writing it for you, but don't assume this is the way we should write. The reason is, there are several other values of x for which this is true. So I cannot just go by 1. Since we are talking about one equation, we have to include all the possible options for which this equation is true. So that's why we don't write it like that. I'm just making it a little bit easy for you, but don't show it to someone else. Now here, at this point, we know that, okay, this is, okay, we have that idea that, okay, this is what we have. But also remember, we can make it a little bit more generic. Now, how we can do that? First of all, this is a function of tangent, right? And every trigonometric functions are periodic, we know it. And they have some period. For an example, sine and cosine, the periods are 2 pi. For tangent, cotangent, the periods are pi. If you remember this, I think this is not too hard, we can just remember this. What we do is, we just write like this. It's just, we'll be just adding n pi with that. Now here, pi means a period. Pi means one period, because you know because it is a tangent, so that is pi. N stands for an integer. I should be a little bit more say integer. We understand the integer, right? All the whole numbers of the world are integer. The whole numbers. Maybe that is negative, maybe that is positive, but the whole numbers, they are integers. Now, why we are talking about integers here? Because we know that after every pi, the trigonometric values for, values for the tangent will be repeating, because that is the period. We know that, right? After every period, all the values will be repeated. For doesn't matter it's a tangent, doesn't matter it's sine, cosine. After their period is over, all the values will be repeated. And that's exactly what it means. This is what it should be, but same value we'll have again after n pi. Now, what is n here? All the integers of the world. N can be 0, n can be 1, n can be 2, n can be 3, n can be -5, n can be whatever. Okay? But in most of our equations, as you notice, the equation here, at the top, x is always restricted, right? Because that's restricted by, that's limited. That x cannot be these. It cannot be larger than these. It cannot be smaller than this. Okay? So that's why we know that even if n can be anything, it will not be anything because of that restriction. But we don't know exactly what n will be at this point. Now, what we do is, we just write n pi here. In case of tangent, if it is sine and cosine, we'll probably write 2n pi. Why 2n pi? Because n times 2 pi. Because the period is 2 pi. You see what I'm saying? We are just writing n times period. That's exactly what we are writing. Since the period is pi here, if it is sine cosine, we'll be writing 2n pi. That means n times 2 pi, because the period is 2 pi. Now here, we'll not stop here because we are trying to find the x. Now the next line, we'll be writing x equals to what? To get the x, we have to divide both sides by 3. We exactly do that. If we divide both sides by 3, what do you get here? It will be x by 12, and this will be n pi by 3, right? We divided both sides by 3 now. Now we already have x, but we'll do this. We will apply all the values of n here and see how far it can go. For an example, we'll do this. We'll take n equals to 0 first, because we know that x can be within some range. If n equals to 0, x is going to be what? Oh, this is pi. I wrote x here. That's pi by 12. We can take this value, right? Because this is within 0 to 2 pi, right? Now we'll check what happens if n equals to 1. If n equals to 1, this is going to be, x is going to be what? Pi by 12 plus pi by 3, right? Look at here. I just plugged n equals to 1 here. So this is what you get. And then if you add, then you will have 5 pi by 12. We can still take it, right? Because this is still lesser than 2 pi. Are you sure? We can take it, right? Okay. So what happens if n equals to 2? x equals to pi by 12 plus, if you plug 2 here, what happens? You'll get 2 pi over 3. I'm just plugging n equals to 2 here because this is our generic equation, right? This is the generic version of the equation. Now here, if you add this, 9 pi by 12. We can still take this because this is less than 2 pi, right? Less than 360, whatever. So n equals to 3. We'll continue these calculations. N equals to 3. That will be another one. At some point you'll see that x is exceeding 2 pi. We'll stop there. You see what I'm saying? Because we cannot take those, but we'll be able to take everything else. This is like a generic way of solving it, and this is a little bit safer than the way we were doing earlier, because earlier we had to really look at the quadrant and think about that, but now, still we are talking about the quadrants and those things, but this makes it a little bit easier because you're just adding the n pi or 2n pi based on the original trigonometric function, okay? Now, can you do this? Just plug 3, plug 4 and see how far you can go. Take all the values. So we did up to 2. I'm sure that you can also take 3, try 4, try 5, and you have to take all the values. Now, in the MyMATLAB, you'll see all the answer. So if you miss one, you probably will be missing the whole question. We don't want you to do that. Just make sure that we get all the values of x. I'm sorry? How do I get these?
No. How do you want to do this?
Oh, and just get all the other values. For n equals to 3, do the same calculation. For n equals to 4, do the calculation and see what is the x. Because, for every n, we are getting x, right? For n equals to 0, we got x equals to pi by 12. For n equals to 1, x equals to 5 pi by 12. N equals to 2, x equals to 9 pi by 12. N equals to 3, there will be some x. So we'll be taking all of those x until x does not exceed 2 pi. Because that's what is restricted by the equation. So we'll take all of those values. If you check here, we are taking n equals to 2, we calculated that. N equals to 3, we did that here. N equals to 4, so we can take all the way up to n equals to 5. Why we cannot take n equals to 6? If you take n equals to 6, you can check. You can always check. If you do n equals to 6, x will be larger than 2 pi. Because it will be something like, let's see, it will be larger than 2 pi for sure. So we cannot go further than 2 pi because usually in the original equation x is restricted by 0 to 2 pi. Anytime if you have any equation where there is no restriction for x, what happens? You will have, like, for x, there will be infinite number of angles for which this equation will be true, and we cannot basically write all the infinite values, right? So what we'll be doing is we'll be just writing a generic equation like this, and we'll stop there. Because we'll just tell, this is the generic equation, n is an integer, just plug any integer for n, you'll have one value of x. That's what we can do, because we cannot go all the way and we cannot get all the infinite numbers, because that's infinite. If we do this, let's try to solve this equation after that, because again, this is the generic version right now. So at this point, we'll be again following the same steps and see whether we can solve this equation. And I'll give you a little time here to see whether you can do it, because this is the same problem. We just have a different equation. We'll be doing the same math. Since we know the generic way of solving an equation, I want you to look at one more problem here, and then we'll compare with the tangent one, because I want to show you something. For an example, we have one equation like this: sine x by 2 equals to square root 3 by 2. Now here, remember at this point, but from this point onward, we'll be always using the generic steps, and then we'll be using the n. Now here, one other thing that probably we need to understand that, for an example, you know that x by 2 can be what? Pi by 3, 60 degree. This is 60, right? Sine, for sure sine 60, right? I did not write the generic part of it. Now, here, one of the things that you have to probably think about that, because you know, in case of sines, since the sine has a period of 2 pi, okay, most of the value you will have at least 2 points where you will have the same value. Because of this, even if you remember the first, for example, if you draw the graph of the sine, cosine, they look like this, right? Now let's say if you draw any line, let's say this is your 180, right? This is your 180, and within 180, look at this. There will be always 2 points where you will have the same value, okay? But in case of tangent or cotangent, what happens? Your let's say your curves are like this, right? Now let's say this is one period, which is a distance of 0 to pi. Now what happens? Draw a line. You will never see that within that period. Within the period, for one value, you will not have 2 angles. You see what I'm saying? What I am saying again, in case of tangent, for one value, you will always have one angle within one period. You will have the same value repeated, but that will be in other period. Here, maybe again. You see what I'm saying? Here. But in case of sine and cosine, within even one period, you will have always 2 points where you will have same angle repeated. You see what I'm saying? And that's why you have to think about this, that for an example, in case of sine, what happens? Let's say this is pi by 3, right, which is here. Another angle will be in second quadrant, which is an angle, which is the quadrant for sine. It may be in somewhere else. It may be in quadrant 3 based on what is the angle. If it is negative, it will be here and here. But remember, there will be always 2 points. There will be always 2 angles for sine and cosine even within one period. That's why when we did the generic equation for tangent, what we did? We just took pi by 4 and added n pi with that. We are done. We just gave the value of n, 0, 1, 2, 3. But in case of sine, you have to do an additional step, even for cosine. Sine and cosine. What you need to do is this. From here, we know that this is okay. There is no question with that. This is fine. And just let's make it generic. To make it generic, what do you do? We just add 2n pi. That's how we make it generic, because the period is 2 pi times n. But one more step is this, because we know that x by 2 will have sine x by 2 will have this value again in second quadrant, right? Because the second quadrant is the quadrant for sine. So how you get that value? That will be this. Second quadrant, right? This is what I'm saying? 180 minus this. Then you will add the period with that to make it generic. So be careful about this point, because we don't have any example of sine here at this point in the slide. So I thought probably we need to remember that in case of sine, even for the generic equation, you'll have 2 different versions of generic equations. 2 different versions of generic equation. Then what you do is, you have one generic equation, plug n equals to 0, 1, 2, 3, and see how far you can go. Because since you have this, if you want to get x, it will be what? Multiply both sides by 2. Then it will be 2 pi by 3 plus 4n pi. We multiply both sides by 2. And here, if you multiply both sides by 2, you will have x equals to, let's make it simple. This is what? 2 pi by 3 plus 2n pi. And then we multiply both sides by 2. And then this becomes 4 pi by 3 plus 4 n pi. Now, this is one generic equation. This is another generic equation. Then what you are going to do is you will plug n equals to 0, 1, 2, 3, see how far you can go until you should go until you exceed, I'm saying that x exceed 2 pi, right? X cannot go beyond 2 pi because that is restricted by, for an example, that's probably restricted by here, let's say. It's mentioned like that. And you will also apply n equals to 0, 1, 2, 3, 4, 5, how long? As long as you do not exceed, x doesn't exceed the 2 pi. So be careful about that. So in case of sine and cosine, for every value, you will always have 2 points, 2 angles within one period because of the, you saw that in the curve, right? In the tangent, there will be only one value. But the sine cosine, you will always have 2 values, even within one period. And just remember, in case of when you make it generic, you will always add n pi in case of tangent. But in case of sine cosine, you will add 2 n pi because their periods are 2 pi. To make it generic, we are just saying that, okay, after 360 degree, this value will be here again. Okay. Any question here? We are not done yet, but we are done with this kind of equations. We will be now solving a little bit more advanced, like quadratic equations. So in all of the equations, you will have some squares, like sine square, cosine square. But again, we will be dealing just like the quadratic versions of equations we have seen in. For an example here, let's look at an example because the remaining steps are same. We don't have to bother about the remaining steps because it's just like the regular quadratic equation. Now here 10 square plus 10x minus 2. If you really want to solve this, there are 2 options. As I said before, one option is factoring. I'll probably show you both for this one. One option is factoring. If you like factoring, because I'm sure that you have done factoring at any point, either in DSPM 850 or any other similar class, you have done factoring. That's one option. But what happens if you don't like factoring? If you don't like factoring, that means we have to use that formula. Remember at the very first class or sometime at the beginning, I showed you one formula for quadratic equation, x equals to minus b plus minus b square minus 4ac divided by 2. I say we'll go by that. Now it's up to you whether you want to use formula or factoring. But the book preferred factoring, so you will not see that formula in the book, but it's up to you whether you want to have that formula, so you can just apply the formula and that will work. Doesn't matter what it is. And also one point I probably want to note here. So, since we know the generic version of the equation, we can always write the generic equations and you can always do that. But in some cases, you can skip the generic versions if you want. Whenever you see that it is only x, like sin x, like cos x, like tan x, you can skip the generic versions. But if you see something like x by 2 or 3x, 2x, 4x, meaning there is some coefficient multiplied with the sign. You see what I'm saying? Let's say 4x, 3x, 9x, or 5x divided by 2 with the x. Something is multiplied here. Okay? Then you should choose the generic version, because what happens is, if you choose the generic version, you see here, even if this is what we have, but after you again do the algebra, because of this divided by 2, you will get something else. That's important here. But if you don't have anything, for an example, this is a quadratic equation, but here with the x you don't have anything. It's not like 2x, 3x, 4x, 9x, or 3x by 2, not like that. So you can still go without generic versions. But generic versions will not harm. If you choose the generic versions, it will always work. There is no question about that. But if you want to, I know some people, they always go by the generic version because they think that, okay, that's only one technique I learned and I'll just go by that. And you plug like all the values of x, I'm saying that n, and see how far you can go without exceeding x equals to 2 pi. So it's up to you. Probably we'll choose generic versions, but again, as I just mentioned, that you can skip the generic versions in some cases. So, let's see whether we, if we're trying to solve this equation, all right, so let's go by, so do you really like factoring? It's up to you, or do you want to go by the formula? Formula? Factoring? Which one? Because the formula is like, doesn't matter what the equation is, as long as there is quadratic equation, the formula will work. Factoring is, if you miss something, it might not be working, but that's easy. But I don't also prefer that you will never learn factoring, because you will need factoring at some point for sure, somewhere. Not probably here, solving quadratic equation. Now let's try to remind the formula. So this is the generic versions of the quadratic equations. Generic versions where A, B, C, these are coefficients. If we have these, then we can always solve an equation by this formula. Negative b plus minus square root of b square minus 4ac divided by 2a. That's the generic versions of any quadratic. Doesn't matter what kind of quadratic equations is this, you will be always solve any quadratic equation. And you will always have two values of x from here, because there are plus and minus. When you take plus, you will get one value. When you take minus, you will get another value. So from that standpoint here, what is your a? This equation, the equation we have right now, what is your a here? A is 1. Everybody see a is 1 here? Because you see the 10 square can be compared with x square here, right? So a is 1. What is your b here? B is still 1. What is your c here? Negative 2. So as long as you know a, b, c, you are done, because then what you are looking for here? You want to find the 10x, because the 10x is the parameter here, right? You are trying to find the 10x. So now let's try to find one value of 10x, and then we'll look at the other one. So negative b plus, let's look at the plus one first. So the b square minus 4ac divided by 2a. Now what do you get here? Negative 1 plus 1 plus 8 divided by 2, which is minus 1 plus 3 by 2, and then 1, right? So 10x equals to 1. That's one value of 10x. Let's write it here. So the 10x equals to 1. This is one value of x, 10x. There must be other value of 10x when you take negative here. This is going to be the negative one, right? Let's write positive and negative both, so we can see everything together. Negative and positive. So it's going to be, if it is negative, then it's going to be negative 2, right? X equals to negative 2. So let's see, 10x equals to negative 2. Now, for what value of 10x equals to negative 2? What is that? Can anyone check with the calculator? We know that for 1 that will be 45. So here the x is going to be pi by 4 plus n pi, right? To make it generic, and then now you can plug n equals to whatever you want. So here, what is negative 2? Anyone found negative 2? What is the angle? You can do tan inverse negative 2, then the calculator will give you the answer. Negative 63.43, which is, the interesting is, let's see, tan x equals to 1, which is negative. So it must be in the quadrant 2. How much you get? So that is here, right? Which is probably here as well, because this is the quadrant for the sine. So all the tangents are negative here as well. So can you can you do pi minus? So just add the 180 with that. 116. So what is that? 116.57. So can anyone check that? What is the tangent? 116.57. What is the tan of this? Oops, that's not accurate. So something was lost in the. I think if we do it in the pi, maybe we can get the right answer, but this is what you get. So that's in quadrant 4. And then we said and then let's take 10 for this. Yeah.
I thought you said it would be entire fraction.
1 point something, so it's in radian. So here, okay, so what will be this in pi? This is going to be in pi because we just got everything in pi right now, because it's probably you cannot write in, so this is probably the best form we have right now. So it's negative 1 point, because this is in pi. I just changed the mode into radian. So that's so the x is going to be here. So 116.5, let's say 57. So 116.57. Let's keep it in the degree, then later on we'll work with the pi, because we can always convert it into the pi. I'm saying the radian just by multiplying by pi times 180. So here, since we have two different values of x, and then we can convert it back to pi. So let's see whether we can do it here right away. So can anyone multiply this with pi and divide it by 180 to see what it is going to be in pi? And 116 by 0.57 times pi. It's already multiplied, I think. Pi 180. 2.03, let's say. That is in pi. Let's write 0.3 here. So, and then to make it generic, we just add n pi with that to make it generic. Now, if you just plug n equals to 0, 1, 2, 3, you will get all the values of all the answer that you will expect. Once you are done, check with this one. This is a cos square x function. So again, the quadratic function of power 2, and you have your formula. Apply the formula and see whether, but remember, you will have always, for each value of cosine x, you will get two angles. So in general, you will have, since you will have two values of cos x, here, for one value we will get two angles, so there will be four angles. And four angles, you will have four generic equations. Just remember, if you are applying the applying the formula for solving the quadratic equation, you have to have everything in the left side, just like the ax square plus bx plus c equals to 0 first. Then you will know your ABC. Okay. So make sure you go to the general form of the quadratic equation, which is ax square plus bx plus c equals to 0, and then apply the formula. Okay, so if you try to solve this equation, which is 4 cos square x plus 4 cos x equals to -1, and then you want to first make it generic to match with the form ax square plus bx plus c. What do you want to do? You want to just bring the -1 to the left side, or you want to cancel it out just by adding a 1 to the both sides? It's up to you. So your equation will be 4 cos square x plus 4 cos x plus 1 equals to 0, right? Because you will be adding 1 to the both sides to make it 0 to the. Now it's matching with the original general equation of quadratic function, and then a equals to 4 here, b equals to 4 here, c equals to 1 here. From that you will know what is going to be the cosine x. So your cosine x is going to be minus b plus minus b square minus 4ac 2a. So this will be 8 -4 plus minus 16 minus 16. This is going to be 0, so it's -half. Did you have the same answer? Okay, now for the -half, which is good because you just have one value of cosine x. So for cosine x -half, now first of all, what is that? -half. What is the angle here? For which value cosine is negative? Now first of all, since this is negative, and as I said that there will be always two angles for cosine, what will be the angles? Second and third quadrant, right? Because these are the only two quadrants where the cosine is negative, right? These are the only two angles where the cosines are negative, all sine, tan, cos. So if it is in negative, if it is in the second quadrant, since the angle is half is what? So it's cosine 60 degree, right? Cosine 60. So is we first write like this, is cosine minus, because it's negative, or maybe I can write this way. That makes it a little bit easier for you. just write half. So half is cosine 60. Right? Cosine 60. So, and then cosine x, since this is a so it's negative half, right? So the x is going to be, since the value of the x is negative, is going to be, one is in the second quadrant, another one is in the third quadrant. Which is in the second quadrant? That will be this. This is the second quadrant, and the third quadrant is going to be this. Pi minus, that means second quadrant, pi plus third quadrant. And if it is in second quadrant, the value is going to be 2 pi by 3. And the third quadrant, the value is going to be 4 pi by 3. Now, to make it generic, I don't see it will be, there will be any more value except n equals 2, because just to make sure, if you want to do that, just to make sure, you can also try this 2 pi by 3 plus n pi. You don't have to do this in this case, because as I said, remember I said that if this is only x, you don't need the generic one. If it is like 4x, 6x, 9x, then do generic one and see. So you probably will not need the generic one, because what happens is within 360 degree, these are the only 2 points you will have. You will have not more than these two, because these are within 360 degree. Okay, that's within the period, because as we know that within period there will be only 2 points and it's only x. If it is like x by 5, then the value will be changing because of that divided by 5. So we do the generic version. So these are the only 2 answers we'll have, which is 2 pi by 3 and then 4 pi by 3. You had the same answer? Anyone calculated before I did? Alright, so we'll stop here for today, and this section is not over yet. So we'll in the next class tomorrow we'll also start from here, where we'll be discussing again solving the trigonometric equations, but in some different using some different methods. But remember, as we know that we are solving equations, and the book tries to categorize the equations into different forms, so that just by looking at the equation you know what method will be good for that. But you don't have to go by only by that. If you know some kind of generic equation like this, or if you just have some equation in one form, you can change it to some other form using trigonometric identities, or using something else, or dividing it by something else. Then all the equation solving techniques will apply. Okay, and once you solve the equation, every single problem will be like this. You will have to think about the angles. All right, see you tomorrow, and don't forget that we have the test coming day after tomorrow, and the quiz 2 will remain open until tomorrow night for the chapter 4, so that you can practice, and also you can always review for sure if you have submitted all the 5 atoms.